In this video, I'm going to do two reaction stoichiometry problems. So I'm going to start here, 17.4 liters of oxygen gas, which is O2. And we're looking for volume of H2S. Volume is also liters. Because O2 is in our given, that is our A. And H2S is what we're looking for, so that is B. We're going to start by putting our given over 1. And then we're going to use the unicorn diagram to figure out how many factors we need. So here we're going from liters of A to liters of B. So liters of A is right here. Liters of B is here. We need one factor for liters of A. Then we go to moles of A, so that's our second factor. Moles of B is our third factor. Liters of B is our fourth factor. So we need 4 factors here. We then take our units. So here we have liters of O2, and we put those on the bottom. So whatever unit you have on the top of one factor always goes to the bottom of the next. So we'll put liters of O2 down at the bottom. To figure out what goes on the top, you look to your unicorn diagram again. So on the first factor, we had liters of A on the top, and we already have that from our given. So our second factor is going to be moles of A. So that's what goes on the top. We have moles, and our A in this problem is O2. Then we drop down moles of O2. And to figure out what goes on top of our third factor, we go back to our unicorn. Our third factor is going to have moles of B on top. So moles, and in this case, B is H2S. We drop that down, and then whatever you're looking for goes on the top of your last factor. So that's liters of H2S in this problem. So now we need to plug in the numbers. To do that, you take the units and match them up with our conversion factors. So if you have moles on top and liters on the bottom, that's this one right here. Moles, liters. So we're just going to copy these numbers into our problem. 1 mole, 22.4 liters. For our next one, we have moles on top and moles on the bottom. So that takes us to this factor with moles and moles. And you'll see here that I wrote coefficient. The coefficient comes from the reaction. So what we're going to do is find our substance, in this case on the top it's H2S, in our reaction. So H2S is right here. Whatever number is in front of H2S, we'll put in front of H2S in our problem. So since 2 is in front of H2S in the reaction, we put a 2 right there. And then we're going to do the same thing for O2. O2 in our reaction is right here. It has a 3 in front of it, so we're going to put a 3 right here. And then our last factor has liters on the top, moles on the bottom. So we have right here, liters on the top and moles on the bottom. So we'll copy those numbers right here. And then to solve, we'll multiply across the top and then the bottom and divide. So we end up with 11.6 liters of H2S. So let's take a look at this one. We're looking for moles of hydrogen peroxide, and we're given 0.241 grams of water. So water is our A, hydrogen peroxide is our B. So we're going to start with our given. And then see how many factors we need. So we'll go back to the unicorn diagram. This time we're going from grams of A to moles of B. So grams of A will be our first factor. Moles of A will be our second. Moles of B will be our third. So we only need 3 factors for this one. Next, we do the units. So we take grams of H2O from the top of the first factor and write it to the bottom of the next one. To figure out what goes on the top of that factor, we go back to our unicorn diagram. We have grams of A for our first one. So we go to moles of A for our second one. So moles, and A in this case is H2O. We drop down moles of H2O. And what we're looking for, moles of H2O2, goes on the top of our last factor. So now we have moles on top and grams on the bottom for this one right here. That takes us to this factor. This factor is a little bit different because we have to calculate X. So we can write 1 right now for moles, and then we have to calculate the molar mass. And X is the molar mass of H2O. So what you do is you look up the decimal number for H, which is 1, and then you're going to multiply it by the subscript for H, which is 2. And then you're going to add that to the decimal number for oxygen is 16, and the subscript is 1. So that comes out to 18, and I put 18 right here in place for X. The last factor here is going to be moles on top and moles on the bottom. So that takes us again to this factor with the coefficients. We find H2O2 in the problem, in the reaction, and since it has a 2 in front of it, we put a 2 right here. H2O also has a 2, so we put a 2 right there, and then we solve. And we get